All right, today we're looking at difference of squares, and we are still factoring, right? We can still see that our final answer is going to have two parentheses, right? These two groups, which is kind of what we think of when we think of factoring. And difference of squares is just a very special case that sometimes happens when we factor. All right, it's a special rule we use when we are factoring a binomial, not a trinomial, right? A binomial, so that means two terms. A binomial expression where both terms are perfect squares, right? Think about some perfect squares numbers that we know. 9, 16, 25, 36, 49, all those things are perfect squares. All right, and it's a binomial expression where both terms are perfect squares that are being subtracted. And it's always subtracted because when we talk in math subtraction, we use the word difference. Like that's why it's called the difference of squares, right? Difference because we're subtracting, squares because we're subtracting perfect squares. So let's take a look. We kind of can see the rule right here. I'm going to ignore the rule for a second, and I'm just going to kind of do what we've been doing. So if I'm going to factor this thing, I only have two terms, but I still have a and c, right? A is still 1, and c is negative 16. B is missing. The middle term is missing. The term with x is missing. So what we're going to write over here is we're going to write, okay, well, a times c is still just 1 times negative 16, so negative 16. B, since they don't write it, since it's missing, we're going to say is 0. So I'm going to put right here, right, we've got to find two numbers that multiply to negative 16 but add up to 0. And that does seem like maybe it's a hard combination, but make your list really quickly and you'll see that it's really simple. We got 1 times 16, 2 times 8, 3 doesn't work, or 4 times 4. All right, 4 times 4. So it's got to be 4 times 4. And since we're multiplying to a negative, one of them can be negative, one of them can be positive, and that's going to cancel each other out, right? This combination will add up to 0. So we're going to go ahead and we're going to keep the x squared over here, and we're going to keep the minus 16. And then in the middle where there was nothing, I'm going to write minus 4x plus 4x. Because these really would cancel. We would have 0x right there, but if I'm going to factor, I want to be able to factor out my two groups. So my first group is going to be over here on the left side. We're going to have x squared minus 4x. And on the right, I'm going to have this 4x minus 16. Okay, then we go about finding a GCF. So for this first group, my GCF is just x. That's all they have in common. So I'm going to put x outside. Once I divide out an x from each term, I'm left with x squared. Nope, not x squared. I'm with just x minus 4. And then I look at my second group. All right, my GCF for my second group is 4, not 4x because 16 doesn't have x. And 4 goes out front of this group. And we are left with x minus 4. Now I've got these two groups that are matching, which is awesome. That's supposed to happen. So one of my groups is x minus 4. And my other group is my GCF terms, right, my green terms, an x and a positive 4. And this is my answer. And just like always, let me remind you that to check our answer, go ahead and just type in your original problem. So we had x squared minus 16 to start with. And when we were done factoring, we had x plus 4, x minus 4, right? And I've got parentheses and everything. Let's check those. And go to the table. Second graph. And we're right. And we can see that we're right because all the y's for each of the same x's is matching, right? All these y's are lining up. Okay, so let's talk about this rule really quickly to see if that could have sped things up. If I think about the front term being a squared and each of these being a, how does that look in my final answer? Didn't I have x squared here? What's the square root of x squared? Don't I get x squared by doing x times x? Didn't I have an x and an x? All right, then think about how we have c squared here. And here we have just c and c. So if this is 16, this is c squared, so c must be 4, right? We've got 4 in both of those places. So if you want to use this rule, it makes it kind of quick, right? And we can see that all we do is square root each of these, and then we've got The square root of a squared is just a in each of those places. And at the end, we've got the c squared. So the square root of c squared is just c in each of those places. And then notice we've got a minus sign and a plus sign. And that's all you need to know. You got to have a minus sign in one and a plus sign in the other because we have to be able to cancel out the terms, which is why they have to have opposite signs. Now, if you don't want to use this rule, you honestly don't have to. The way we've been doing it totally works. This is just kind of a shortcut that you could use sometimes. All right? So I'm going to go ahead and I'm going to do this middle problem, and I'm going to use the rule. All right, so let's make a quick note. Here is normal factoring method, right? Normal factoring method. And now for the next problem, I'm going to use difference of squares rule. Either way works. All right, but on this next one, I'm going to use the difference of squares rule. So let me write it here real quickly. If I have a squared minus c squared, when I factor, I'm going to get a minus c and a plus c. Okay, so let's talk about what that means. 4x squared is a perfect square because to get 4x squared, I can do 2x times 2x, right? That means it's a perfect square because it's something multiplied times itself. I think we know 25 is a perfect square because it's 5 times 5. So if I'm going to go ahead and I'm going to write my factored form, then I can just go ahead and write my parentheses here, right? So the a squared means that I get a in both of those first spots. So what's the square root here? How do I get 4x squared multiplying something times itself? We already talked about it. It's got to be 2x and 2x, right? Wouldn't that give me 4x squared if I multiplied? It would. And the square root of 25, right, just like we have c squared here and then regular c, I'm going to put 5 and 5, right? That's how I would get 25. And because it's the difference of squares, we know that we have to have opposite signs inside. That's why the middle term cancels out. And so I'll put a plus sign and a minus sign. Or you know what, to make it match the formula, we'll do a minus sign and a plus sign. It doesn't matter which one is which. All right, and this is my final answer. So I didn't have to do all the grouping if you can recognize when you have this special situation. So let me check my answer really quick. I started with 4x squared minus 25, and then I ended up with 2x minus 5 and 2x plus 5. And I'm going to check my table here to make sure that my y columns are matching. And they are, so we are good. All right, so kind of be thinking about in your head right now, do you like that you could use a shortcut, or do you just want to do it the normal way because this way always works, right? This way doesn't always work. It only works if you have a perfect square minus a perfect square. Okay. Again, last two examples are for you guys to try. I'm going to go ahead and I'm just going to do them both, and I'm going to do this quick method, all right? Since it's x squared minus 49, this is a perfect square because it's x times x. And this is a perfect square because it is, it is 7 times 7, right? So my final factored form here, because I have the difference of squares, is going to be x and 7, and one needs a minus and one needs a plus. And that's my final answer. The last example, real similarly, I've got a perfect square, right? Why is this a perfect square? Because it's just 3x times 3x. I've got another perfect square because this one is 8 times 8. So in my factored form, because it's the difference of squares, again, it has to be subtracting difference of squares, I'll have a 3x and a 3x. I'll have an 8 and an 8, one with a minus, one with a plus. Remember, these have to be opposite signs so that middle term will end up canceling. All right, and that's my final factored form. One more time, I can't say it enough, this does not always work, y'all. Only works if you've got the difference of squares, two perfect squares being subtracted. Okay? If you can remember that this is a rule, then it makes your life real easy, when you have this case because it kind of cuts down on all this long work that we usually do.